All right, gang, we're working on worksheet 1.4, 1.5, angle relationships in algebra. We're going to be on page 3 here. We have 3 questions that we're going to do here on page 3. The first question here says that we should use CUBIXS to help set up and solve the following problem. So we're going to read what we have here and use our CUBIXS strategy. It says the measure of one angle is 3 times the measure of its complement. Find the measure of each angle. So we need to circle the numbers that we have, which in this case, we just have this one word right here, 3. Then we need to underline the question. It says, find the measure of each angle. Then we're going to box the important geometry words. And the one word from our unit is complement. And then there's another word here, another math word that we see in its times. So we're talking about 2 angles, has the word complement, and we're going to go 3 times, and we're going to find their measure. So we're going to draw a picture, and when I think of the word complement, I think 90 degrees, so I'm just going to draw a picture that has a 90-degree angle in it. But I know that complement has to be 2 different angles. So here's kind of a cheating way of doing a complement. Draw this right angle, and then here's my 2 angles right here that have to add to 90. I do know that one angle has to be 3 times the measure of the complement. That means that one of the angles has to be 3 times the other angle. So if I go 3 times x, that means the first angle has to be x. So here we have 2 angles. One is x, one is 3x, and I know together they have to make 90 degrees. So when we, after we have our picture here, we're going to set up and explain that complement means 90, and we have x plus 3x equals 90, or again, we can do our mental math, 4x equals 90. And then what I'm going to have you do is find out what x equals, and then I want you to take that x value and plug it in to those 2 spots right there to find the measure of each of them. And your when you add them together, it should equal 90. So I'm going to pause right there and let you figure that out. And then I'm going to jump down and work on questions 30 and 31 after you have finished 29 there. All right, we're going to unpause this guy and we are going to work on these next 2 questions here. It says, using the ideas of linear pair and vertical angles, find the values of x and y. When you look at the diagram for 30, you see that we have these 2 lines that cross each other. We have 2 angles next to each other that could be considered linear pairs. And we also have the 2 angles that are opposite of each other that could be considered vertical angles. We have both the ones above and below, or top and bottom, and we have the ones on the left and the right. What I notice in these questions is that these 2 expressions are the 2 that have x in them, and when I'm doing a problem, I think that probably the x's should go together. So when I look at those 2 angles, I have to figure out what kind of angles they are, and it turns out that those are our vertical angles. And when we have vertical angles, I know that those are equal to each other. So I'm going to write 3x plus 7 equals 5x minus 35. So when I solve this, I'm going to move the smaller x with the larger x by subtraction. Bring down the 7. Add the 5x minus 3x for 2x. Bring down the minus 35. Then I'm going to move my 35 back by adding 35. So bring down the 2x. 35 plus 7 would give me 2, carry the 1, 42. Divide by 2's there. and I get x equals 21. So now I need to find out what y is. When I go back and look at the question, I notice that the two y values are also opposite of each other, and so I'm going to set up an equation with those two, and I'm going to write y plus 75 equals 3y plus 5. And when I solve that, I have to minus y to both sides. Bring down the 75. 3y minus y is 2y. Bring down plus 5. Minus the 5 to both sides. 70 equals 2y, and divide by 2, and I get y equals 35. Go back and look at the directions, and it does say find the values of x and y. I have those two values right there. And so question number 30 is finished. What I'm going to do here is clean this up, and then let's look at 31. It's slightly different. So I'm going to get that fixed up. We'll pause right here. All right, now we're going to unpause, and we're going to look at 31. When I look at 31, I notice that I have x's here and I have x's here. So if I were to highlight those x's, I notice now that they're not pointing at each other, but they're right next to each other. So look over here, we had this x and this x, how they pointed at each other. Now here we have them right next to each other. In this case, those x's are a linear pair, and those add up to 180 degrees. We only have the one y right here. It's all by itself. So in this case, we're going to do the x's first and then go back to figure out what y is. So we have the 6x, plus 15x plus 75 equals 180, because those are linear pairs. Or remember, we can do our mental math. 6x and 15x, that's 21x plus 75 equals 180. We can solve this by subtracting 75 from both sides. Bring down our 21x. 180 minus 75 is 105. Divide by 21 on both sides, and we're going to get x equals 5. So again, that's one of our answers. Now we have to go back and find out what y is. Now when I look back at the picture, I do notice that those two angles are right next to each other. And if x equals 5, 6 times 5 has to be 30 degrees. And so what would I put with 30 degrees to make 180, that linear pair? That means this has to be 150 degrees. So there's my second equation. 3y equals 150. Divide by 3's, and y equals 50. So I just wanted to point out that in question 30, we have vertical angles, and in question 31, we have linear pairs. So question 30, we used equal in our equations, and question 31, we did addition and equal to 180. So pay attention, you have two different kinds there. Now you're going to work on question 32, and you're going to figure out, when you look at the question, is this one more like question 30, Or is it more like 31? So use those two examples to help you with 31. Now I'm going to pause this video and I'm going to get started on the next page, page 4. If you need help, check back with me.